Bismillahirrahmanirrahim. Assalamu alaikum to all my dear viewers. Today I am going to facilitate the electrostatics and lecture number 2. In the previous lecture number 1, we have discussed about the brief explanation of electric charge, and after that the unit of electric charge, and then we have defined in a very simple manner, and the third step was the quantization of charge. So actually I wrote a formula that Q is equal to NE. Basically, what is Q is equal to NE? N represent whole number, means 1, 2, 3 up to N or infinity. So the N represent that the electron is totally displaced from one body to another body, and this phenomena is called the quantization of energy. Quantization means the electron cannot partially move from one body to another body. And after that we have discussed the conservation of charges. Conservation of charge mean if I have an isolated system consists of two bodies A and B, and let's suppose the A have a charge of -2. -2 means this body have efficiency of 2 electrons, while this body have a deficiency of 2 electrons. But when I see at a macroscopic level, mean from the external view, then I observe that the system is totally neutral, and this technique is called conservation of charge. So I have also defined the technique, but don't realize the technique as a conservation of charge. And most of viewers personally contact me that, sir, what is quantization and conservation of charge? So I am hopefully that you have understand the conservation and quantization of charge in a very well manner. And after that we have discussed what is Coulomb law. So basically Coulomb law was represented from the experimental data performed by Coulomb. Now we move toward the Coulomb law in vector form. In the previous lecture we have discussed the Coulomb law in a magnitude form, but here inshallah I will represent that in which techniques the Coulomb law can be calculated if I take the force and the radial distance between their centers in a vector form. So I move toward the lecture number 2, and if you have any confusion about the electric charge, then inshallah I will prefer to my lecture number 1, which is available at my Facebook IT. So for example, if this body has a charge of Q1 and this body have a charge Q2, and the distance between their center is R. Now the R will be taken in a vector form, and the direction is represented by from body 1 to body 2. So I will write this R as a R12. 12 means the vector is directed from 1 to 2. If I write R21 mean the direction of the radial vector is from 2 body towards the body 1. So here you have to clarify the confusion, and all these distances are measured from some reference point, just like I have a frame of reference and I measure its distance from this frame x, y as a r1, and this vector from my origin of my system is, let's suppose, r2. So how can I calculate r12? Just by subtracting r21 vector will be given by r2 vector minus r1 vector. So here is a brief explanation that how can I calculate the vector from the algebraic method. So what will be the direction of force? The force exerted on body 1 due to body 2 is equal to Q1 Q2 divided by 4 pi epsilon, and here I take the magnitude of R, but here I will take a unit vector, and the unit vector is basically 1 2. 1 2 mean basically this is the magnitude of electrostatic force which we had calculated in the lecture number 1. So I can write F12 is equal to F12 with a magnitude, and R12 is its unit vector. And you have a brief explanation about the vector, that any vector just like R is written as magnitude with its unit vector. So I give its equation number 1, this equation number 2, and I name this is equation number 3. So when I calculate the unit vector, then this magnitude will divided by the vector. So I obtained R vector divided by R is equal to R unit vector, or just if I giving the names 1 2, so here I also place 1 2, and then I put this equation number 4 in equation number 1. So I will get F12 vector. Basically this force is in vector form. So this vector equation 1 become Q1 Q2 divided by 4 pi epsilon into R12, and here R12 with a vector divided by R12. When this magnitude multiply with the R square, it will become Q1 Q2 divided by 4 pi epsilon R1 2 3. And here I will use the vector R12 F12. So the equation number 5 represent the vectorial form of the electrostatic force which we result from the Coulomb law. So here I place R cube. R cube, why? Because here I have placed r vector instead of its unit vector, because unit vector has a magnitude of 1, but this vector has some specific magnitude which will be obtained from equation number A. Similarly, according to third law, when the force exerted on body 1 due to body 2, this body will also experience some force which is equal to F21. So basically, what is F21? The force experienced by body 2 due to body 1. So this will become Q1 Q2 divided by 4 pi epsilon naught R21 cube into R21 vector. So this will become equation number 6. But here the direction of this F21 will be minus. Why minus? Because action and reaction, if the direction of F12 is along x positive, so the direction of F21 will be in the x negative, and I will write according to third law F12 vector is equal to minus of F21. Basically, the minus represent just the direction of the force exerted by Q1 on Q2. So here, in the equation number 7, the Coulomb law is going to completion, and after that I am starting an electric field. So basically, what is electric field? You all are familiar about the field. Just like, for example, if you are playing a cricket and if you have a pitch and here is some boundary around this pitch, so I have some question from you. If you are a captain, would you place fielders above the boundary line? Your answer will be no, because the field is inside the boundary. Because here we have no reason by placing the field, because here the effect of process which is observing on this pitch is not by this fielder just 1, 2, 3. So the field of any pitch, the field of any cricket is observed at some boundary layer. So in a simple manner, if I have some charge body, just like I have a Q, for example, just like Earth gravitational field, the Earth gravitational field is basically region around an Earth in which the effect of Earth can be felt by some mass. So the region around, or the space around this Earth, is called Earth gravitational field. Similarly, if I have some charge, and if I place a charge at some distance from this charge, and if this charge is not attracted or repelled by this charge, means that this marker is outside of the field defined by this body. But when I place or bring this charge or this body towards the other charge, and a point come when this charge will automatically attracted toward the charge, mean now this charge come in the field of that body, let's suppose Q. So basically, electric field is defined as any space. I am using a space. Space mean three-dimensional: X, Y, and Z. Basically, the field of any charge will be observed also in X, Y, and Z. So basically, the electric field is a space around any charge in which its effect can felt by any test charge. Here the question arises, what is test charge? This charge is called source charge. Source charge. Source charge mean of which I am finding the electric field, and this is called test charge. The body which have two characteristics, positive nature and unit magnitude, will be called as a test charge. So basically this test charge is used to study the effect of this charge in its field. So electric field is defined the region. Electric field is just a space, it is not any physical quantity, and inshallah I will move toward the electric field intensity. So what is electric field? The region or space around a charge body, in which its effect can felt by an other test charge. So how much force is exerted by this charge on a test charge is called electric field intensity. Don't confuse or match electric field with electric field intensity. So I have defined that what is electric field intensity? The force exerted by this source charge on this test charge, but the condition is that the test charge will first come in its electric field. So the force exerted by any test charge in its field is called electric field intensity, and I have well known about the force, that force is equal to q naught divided by basically q1 I place a capital Q and a q2 as a q naught mean test charge, and 4 pi epsilon naught r square, and second one q naught, to q naught cancel with each other, and I obtain q is equal to q by 4 pi epsilon naught r square. So in the equation number 8, the equation number 8 represents that electric field intensity has two factors. One is E proportional to source charge, and the second factor is 1 by r square. Mean if the source charge has a large magnitude, so the electric field intensity observed by test charge is also in a large quantity, because this is a direct relation. But if I bring this charge close to the source charge, the intensity observed by test charge is in a large quantity. So when I decrease the R, the electric field intensity will increase, but if I increase the source charge, the electric field intensity will also be increased. And what is its SI unit? Newton per Coulomb, because the unit of all physical quantities will be derived from their main equations. Now I move toward electric field lines. Basically these are lines. First of all, I have to clarify that what is line. Second one is line segment, and third one is a ray. Line is basically the shape which have no endpoint, and line segment basically if I take any part of its line, this is called line segment, and array which have one endpoint and a one emerging point. So basically electric field lines, basically if I have two charges just like Q and other is Q1, and here is some attraction between them, so let's suppose attraction is observed for a Q positive and negative, or if they have opposite charges. I have also taken as positive for Q1 and negative for a Q, capital Q, but I take the capital Q as a source charge and Q1 as a test charge. So some force is observed or emerging from this source charge which move toward this Q1, and basically these lines are called electric field lines. So basically these lines will emerging. Why emerging? Because due to the direction of R vector. So here is a reason, and the second reason is the conservation of energy. Basically the how much energy radiated or emerging from this source charge will totally absorbed by this Q1, and in this way the Coulomb law will also result for the conservation of energy. So these straight lines around any source charge which represent or give me two informations. The first one, the direction, electric field line basically give me two information. First one, strength, and second one is direction. Strength mean if I am standing near to the source charge, these lines are very close to each other. Close to each other mean the strength of electric field intensity near to this source charge is in a large quantity, and when I am moving away from the source charge, these lines will diverting mean the strength will decreases. And the second one is giving the direction, and also the direction is represented by a unit vector. So basically electric field lines are those lines around any charge which give me strength and direction of electric field intensity, called electric field lines. And these lines I have explained that they emerge from positive and entering into a negative, and here is the main reason represented by its unit vector. Now I am moving toward electric flux. What is electric flux? Flux is basically I prefer as a pressure. Pressure mean force exerted on any cross-sectional area. And here the question arises that what is cross-sectional area? What is surface area? And the other one is cross-sectional area. For example, if I have any pipe, just like, and I place a positive charge inside it, so just like I have a marker. The marker, this area is called surface area. And if any fluid is present in a marker, then the fluid will emerging from this area, and this area is called a cross-sectional area. So basically the surface and cross-sectional area both are perpendicular to each other. So what is cross-sectional area? Cross-sectional area is a vector quantity which is always directed or perpendicular to the surface area, and here the direction of this cross-sectional area is represented by delta A. And some source charge mean positive charge is placed inside it, and some electric field lines will emerges from this source charge, and some electric field lines are also passing parallel to the cross-sectional area. So the pressure is basically built up when these electric field lines are passing parallel to the cross-sectional area. These electric field lines have no pressure observed by this cross-sectional area. So here I use a dot product, and you all are familiar about dot product. Dot product is basically the parallel multiplication of two vectors to result a scalar quantity is called dot product. So basically electric flux is the dot product of electric field intensity with the cross-sectional area, and it will give me the pressure observed at this cross-sectional area due to any source charge. So I use phi for the flux, and the flux is basically due to electric charge. So here I subscript E for the electric flux, and the electric flux is a scalar quantity because I have clarified by the definition of dot product. And one video is also available at my Facebook ID about the dot product, cross product, and also the multiplication of different types of vectors. So I can define electric flux, the dot product of electric field intensity with the cross-sectional area, or in other words, the electric field line passing parallel to the cross-sectional area called electric field lines. And for example, if I have any source charge Q positive, and this here is a cross-sectional area, and two lines are emerging just like from this source charge, so I call this is E1, and this one I call as a E2. So I can calculate the flux due to E1 as a E dot A, but here the E2 makes some angle with the delta A, and also one video about the trigonometric ratio is available at my ID. So I will resolve this E2 into its components, because I am saying that physics has a no concept if vector is lying between the two axes. If any vector is lying between any two axes, then I will resolve into its components. So I have said that the vector or the component of E or opposite to the theta is taken as E2 sine theta, and the vector with the side of theta is taken as E2 cos theta. So the E2 is in this way resolved into two components, and this component is perpendicular to delta A. So I will skip this component and will take E2 with the delta A. So here I take E2 cos theta with the delta A. Here I miss the vector because here I am taking the magnitudes of electric field intensity and also the magnitude of the cross-sectional area. So I skip this cos theta from the bracket, so it become E delta A into cos theta. So here the equation number 9 is the final result obtained for electric flux. So electric flux has three factors. First one is electric field intensity, second one is the cross-sectional area, and the third one is the theta between delta A and electric field intensity. From the definition of mathematics, that the E and phi are directly proportional to each other. Directly proportional mean if more electric field lines are passing through this cross-sectional area, then the electric flux will be in a large quantity, but by taking the area and a theta in a constant quantity. And similarly, if I take a large cross-sectional area, so large electric field lines will passing through this cross-sectional area, and I observed the electric flux in a large quantity, but the third component is the theta. Basically, inshallah, I will develop one special lecture on a Sunday about why cos 0 is 1 and cos 90 is 0, and here is also as some other trigonometric ratio, just like sine 0 is 0 and sine 90 is equal to 1. So if the angle between electric field intensity and cross-sectional area is 0, 0 mean the EA into 1 mean 100%. In a physics where I obtain 1 mean 100%, 0.5 mean 50%, and 0.2 mean 20%, and 0 mean 0%. So when the angle between the electric field lines and a cross-sectional area is 0, the I observed electric flux in a maximum quantity. But if the electric field lines make a angle of 90 degrees with the cross-sectional area, and I have also explained that this electric field lines will exert no pressure at this cross-sectional area, so in a similar manner EA for cos 90, it will give me a 0 result and I obtained 0 flux. And the third one case is, for example, if I am taking negative charge, just like this case is not present in a books, but the question arises in some observer that if a negative charge is placed inside a body, so what will be its flux? So this is the direction of A and this is the direction of electric field intensity. So here the angle is 180 degree and cos 180 degree is equal to 1. Inshallah, I will make a lecture that why cos 180 is equal to -1. So here EA cos 180 is equal to -1. So I will result EA. So in this way I take equation number 10, 11 and equation number 12. The equation number 10 give me a maximum flux and equation number 12 give me a minimum flux, but the equation 11 give me a 0 flux. And after that, please note it by pausing the lecture, and inshallah I will move in the tomorrow lecture that what is Gauss's law. Basically, I have explained in the lecture number 1 that any law is the solution of any problem, and the electric flux is observed for those objects in which the cross-sectional area or the area is in a plane. If I take area in a curved path, this formula is not applicable. So the Gausses make some solutions for calculating, because the problem was that if I have some spherical body, and how can I observe or calculate the flux at its boundary, because the spherical or the sphere has a no cross-sectional area. So inshallah, wait till for tomorrow lectures. Inshallah, we will meet with a new lecture, and inshallah we'll define the Gauss's law in a very interesting manner, because I have said that any law is the solution of any problem observed due to society or some researchers. And inshallah after that we'll move in which field the Gauss's law is applicable, and after that a very special topic is the voltage, because 99% students are confused about what is voltage, what is potential difference, and what is electromotive force. Take care. Allah Hafiz.